Now we started the recording. Let's continue. So here we created a data item with that value, and we have the new item. The next step is to add. The next step is to add this item to the list, starting from the first item. So this is kind of the structure of our list. We have first item, then this first item point has a reference to the second item, which hold a reference to the third item, which also hold a reference to the fourth item, and so on till we do not hold a reference to anything. So this is how it is. In order to append this new item to the list, we have to loop through to till the last item. So the last item is the one who doesn't have a reference to a next item. So we first have to check if the list is empty. So when the list is empty, the value for the first item is null, meaning the value of this variable is null. So if first item, if the value of the first item is equal to null, then the first item is the new item. Else, that means there is more. That means the list is not empty. So we have to loop from the first item to the last item. So we use the while loop. We're going to declare a variable that will represent the current item in the loop. And it is a pointer because we want to jump from item to item using their addresses. So the current item is equal to the first item. And while the current item next is different than null, that means it is not the last. The last item always hold a reference to um, uh, has a reference to to nothing. So here we're looking for the last item. So for every item who has a next item, that means it is not the last. So if the first item hold a reference to the second item, that means the field next data item is different than null. So we have to move to the next item and to the other next item till the other next item. For more understanding, I'm going to name it last item. So the last item should be the last item, next data item. So if there is a next data item that follow the last item, that means it is not the last, so we have to move to the next. So when we found the last item, this loop will end because at the fourth item, for example, next data item will be null. Then we know that this is the last item. Then we can now append the new item to the list. So we say last item, next data item is equal to new item. So now the new item will be here. And the new item doesn't hold the reference to anything. And this is how we add element or append elements to a linked list. So we have an element, we had a value, then we create an item, and after that, we have to look for the last item in order to append the new item. So if the new item is null, that means there was a problem, we stopped. But if not, we first have to check if the list is empty. So here we used um, this a pointer to a pointer. We're going to explain it, but let's continue. So here we check if the first, if the list is empty, that means there is no item inside. So the new item is the first item. In case the list is not empty, we have to look for the last item. And the last item is the item which doesn't hold a reference to any other next item. So we have last item. Well, the last item next data item is different than null. That means the last item is not the last item. So the last item become the next data item. And so on till we find an item that doesn't hold a reference to null. Then after that, when we found the last item, we can say last item next data item will be the new item. And after that, the last item is now new item. We can stop the program here. Let's try this out and see how it works. So I'm going to compile it. And for now, we have only one item. And let's compile and append other things inside. So first item, we pass in the address of the first item, then the append function will loop starting from the first item. It will jump from reference to reference till it finds the last item. So we append another value, we pass in the address, -1. And here we call the append function. We pass in the address of the first item. And great. GCC main.c o main. Then we run the function and see here we have it 56, 30, 13, -1, 58. So now let's get back on why we used a pointer to a pointer. So when you declare a variable inside a function and you want another function to modify the value of that variable from somewhere else, you have to pass in the address of that variable. For example, the first item variable here, we want the append function to be able to set its value. For now, it's null, but we want it to the append function to change the value in case we need to. But now, what is the problem is that if you do not pass the value for the first, if you pass in like that, here, you pass in like that, that will only pass its value, not so the append function won't be able to change the value stored in the actual variable. So we say, okay, the append function to receive a reference to this variable. So when needed, it can change its value from null to something else. So that's why we use a pointer to a pointer, a pointer to a pointer, because uh, first data item is a pointer. So in order to have a function that holds a reference or that receive a reference to a variable that has this data type with data item start, so we have to add one start sign. This will indicate that the append function will receive an address of a variable that is a pointer to a data structure, a data structure of data item type. Great. Now we know how to navigate or how to add elements in a data item. Basically, we can also look through the items and count how many items we've been able to see. We're just going to take this function and compute the number of items. So that will be item counts. And here I am going to make the function will return an integer, and we declare a variable called counts. Instead of printing things, we're just going to say counts plus plus. So every time we're able to move to the next item, that means we add one to count, then we return count. And basically, let's go back in our function and let's display the count. So I can say printf, the count will be equal to uh, item count. Then we pass in the first data item. So if you notice, item count doesn't receive the address of first item because item count do not have to modify the value contained in the first item variable. So it just need to know the address of the first structure, then we'll look through all of the other next structures. Let's compile this code and see what will happen. GCC main.c, O option main. So we say main, then here it is. We display the items and there is 4 items in our list. So if you have any questions, you can add the questions. Anyway, the video will be available on YouTube, and also you can ask question in the WhatsApp group. So in order to manipulate linked list, you just have to know how to jump from one reference to another reference using the pointers. So this is one. So what happens if we appended an element to the linked list, but what if you want to add an element to this, you want to change the first element? Instead of appending to the list, you're going to add it to the start of the list. So that means whenever you add a new item, instead of appending it here at the back, you're going to append it at the start. We have a similar code, but this time it is much simpler. We're going to create a function called shift. I'm just going to copy this code and change a bit what is inside. We call it shift. And after that, we create a data item. And we also have, for now, we don't need first item, last item, because we don't want to, we're not appending, but we're adding to the first. Since we already know the address of the first item, we don't need this variable. And also, and here, this loop is going to change. So this is how we're going to add an item. First, if the list is empty, the first item will become the new item. But if the list is not empty, the new item will point to the first item. Then it become now the new first item. So if you add another new item, this new item also points to the head of the list, so the first item of the list, and so on. So it's easier to add an item at the start of the list than the end of the list, because we don't have to look for the last item in the list. Great. So if the first item is null, that means we say new item. But if the first item uh, is not null, we're just going to say the new item is the next data item that follow the new item will be the first item. Then we have to change first item value to new item. So this is one way of doing it. So this is it. You have a new item that points to the first item, and then the first item become the new item. We don't even need the first if statement, because whenever the first item is null or not doesn't matter for this particular case. You can just say we have a new item, and the new item point hold the reference to the next to the first item, and the first item became the new item, and we can delete that. And that's it. When you have a first item, you add a new item that points to the first item. Then the first item, we have to update the variable using its address. So we use the dereferencing operator to change its value to the address of the new item. Okay, someone said that the battery is gone, but the video will be available on YouTube. Hope we'll see you there in the WhatsApp group. Now let's go and see how to use this new function called shift. So append will add to the back, but shift will add to a start. So let's say shift, we have first item, then we add 10. For example, let's say we're going to use the shift function like that. We say we add 1, then we add 2, 3, 4, and 5. So since we passed the address of the first this variable, the shift function will be able to change its value. Um, then the printf function will receive the address of the first elements or the first item, and it will display it. Let's compile this code and see what will be shown. And here it is. We have uh, we've got uh, going to yes, here we added elements 1, 2, 3, but it displayed 5 for in the reverse order. So this is when you add element from the start. So you have something like the first you have 1 in the list. The first elements when you add in the list, you have 1. Then after that, you have 2 that hold an address to the data item 1. Then you have 3 that hold a reference to the data item 2. And then you have 4 that hold the reference to data item 3, which holds the 2, 1, and so on. We can continue on and on and on. So this is the 2 ways we add elements to a list, but there are other ways. For example, you can insert elements in a list. For example, what if you want to insert a value between the second and the third element of the list? This is also possible, but we're going to stop for these 2 examples. Now, so if you have any questions, you can ask in the chat, but the video also will be available on YouTube. Now, a last example, I said that we're not going to do the insertion, but I think it's a good exercise. Yeah, we're going to left this one for now. Yeah, someone raised hand. I have a problem with my with the headphones. I'd suggest you to ask the question in the chat because I can't hear from my headphone. So this is it. We're going to stop the recording. Thank you.